Hi, everybody. Now we're going to do section 1.4, and that's functions. And functions, of course, is a very big part of math, very big part of calculus, very big part of a lot of stuff. So functions is when basically one thing depends on another thing, like a sales tax. The tax depends on what the price of the item was. The distance depends on the time and the speed. The area depends on the radius and stuff like that. So when one thing depends on something else, that's a function. The domain of a function is what they call the independent variable. That's usually the x values. The range of the function is called the dependent variables, meaning that the y value, which is the range, usually depends on the x value, which is the domain. Function, you can think of a function like a machine. I stick an x into the machine. The machine does its thing, and it spits out a y. So in this example here, if I spit in x equals 1, it would do 4 times 1 plus 3, and it would spit out a 7. I'm just saying. Okay, now, is something a function or not? How can you tell? Because in order to be a function has to have it where, let me see, a function has to have one quality, which is that if I stick in one input, I can only get one output for any given input. In other words, I can't stick in a 1 and get a 7, and then later stick in a 1 and get a 12. That's no good. It has to be the same. I have to know what output's going to come out before I put the input in. Every input can only have one output. That's all I'm trying to say. It can't be like, oh, sometimes you get a 7, sometimes you get a 4. It can't be like that. So are these functions or not? And so A is a function, because I can say y equals 1 minus x, and yes, any one value of x determines only one value of y. This one here is actually not a function, because if x, for example, let's say x equals 0. So if x equals 0, y would be plus or minus the square root of 1. So y could be positive 1, y could be negative 1. So a given x value can give me 2 possible y values, so that makes it not a function. On the other hand, here, I can solve y equals 1 minus x squared, and there's no, if x equals positive 1, then I know that y is going to be 0. Now, if x equals negative 1, y is also going to be 0, but that's okay. I don't care if there are two different x values. I don't care if two different inputs give me the same output. That's no problem. But if one input gives me two different outputs, then it's like schizophrenic. And I hope that's a proper use of that word. Might not be, I don't know. So here we have x plus y squared equals 1, but I get y equals plus or minus square root of 1 minus x, and that's also not, again, because if x is equal to 0, y might be positive 1, y might be negative 1. So these are not functions. These are not functions. Now, this was the first problem, that was the second one, third, and fourth. Now notice that the ones that were not functions fail what they call the vertical line test. If I would draw a vertical line, it would hit the guy twice. And if I draw a vertical line here, it hits it twice. So that's what they call the vertical line function, vertical line test. And now the domain and the range of a function. So the domain is basically like, all the x values, and the range is the y values. All these, meaning the x values that could possibly go into the function, the y values that go into the function. For example, if you have y equals the square root of 1 minus x. So if you look at the graph here, it's not every x value in the world. It's only x values that are greater than or equal to 1. And it's not every y value in the world. It's only y values that are greater than or equal to 0. That's fine. That's still a lot of numbers. But there is the domain and the range are not just everything. They're what they are. So the domain has to be x greater than or equal to 1. Another way of writing that is 1 comma infinity with a square bracket by the 1. And here is y greater than or equal to 0. Another way of writing that is 0 comma infinity with a square bracket at the 0. Why is it a square bracket, not a round bracket? Because of the equal sign, greater than equal. If it was just plain greater, then it would be a round. Okay, now, here we have y equals 1 minus x when x is less than 1. And then y becomes square root of x minus 1 when x is greater than or equal to 1. Now, if you graph that, you see this guy right here, boing, that's what it winds up being. So the domain is all real numbers, The range, again, is just y value is greater than or equal to 0. So the domain is all real numbers. The range is just greater than or equal to 0, similar to the previous problem. So interesting. Okay. Moving on. There's something called a function being 1-to-1. 1-to-1 is when every x value has one y value and every y value has only one x value. That's when you have both. That's a special kind of function. So it has to pass the vertical line test and also a horizontal line test in order to be a 1-to-1 function. So a 1-to-1 function is a special kind of function. That's all I'll say. Okay, now function notation. So if I can isolate the y, that's my function notation. So you started with the equation x plus 2y equals 1, but I isolated the y, and I got y equals 1 minus x over 2, and then I can replace y with f of x, and that's function notation. So for function notation, you solve for y if possible, and which is not always possible to do that, but you solve for y if possible, and then you just replace y with f of x. Y and f of x are basically interchangeable. And now, once it's in that notation, I can plug in x equals 3. So f of 3 is 1 minus 3 over 2, which is -1. And that's called, and that's the function value. Function value is -1. So we want to find the values of the function 2x squared minus 4x plus 1 when x is -1. And then we want to do it again when x is 0. Then we want to do it the third time when x is 2. We also want to know if this is a one-to-one function. So let's take it one step at a time. Let's actually start with that right there. So if I have -1, I plug -1 into the x value. So it's 2 times -1 squared minus 4 times -1 plus 1, which becomes 2 plus 4 plus 1 equals 7. If x is 0, I just get 0, 0 plus 1. So the answer is just 1. And if x is, which means that 1 is going to be the y-intercept. And if x equals 2, I stick that in. 2 times 2 squared minus 4 times 2 plus 1. And pow, there's my answer there. So two different values of x yield the same value of f of x. Therefore, it is not 1, 1. See, I get a 1 there and a 1 there. And again, you look at the horizontal line test, it fails if it passes the vertical, so it is a function, but it fails the horizontal. So it is not, so it's a function, but it's not a 1-to-1 function. And that's okay. Not every function has to be a 1-to-1 function. Okay, let's look at this guy here. Let's evaluate x squared plus 7, and we want to plug in x plus delta x. And here we want to plug in, well, we'll do a, first we'll do a. So f of x plus delta x means I take the x plus delta x, I stick it into the x squared, so it's x plus delta x squared, and then plus 7. Now if I multiply this out, again, like binomial, like a FOIL it out, I get x squared plus 2x delta x plus delta x squared plus 7. Don't forget that middle term, because when you have to FOIL it out. And there we go. Now, if I subtract f of x from the previous answer and then divide the whole thing by delta x, so what I'm going to wind up getting is x squared plus 2x delta x squared plus 7, then minus f of x itself. So it's minus x squared minus 7. And then I'm just left with 2x delta x plus delta x squared, all that divided by delta x. But now I could factor out a delta x on top, cancel it out. And my final answer is 2x plus delta x. Now, this is going to be a very familiar, by the time we finish this class, this structure here is going to be very, very familiar. I'm not going to give anything away, but it will become a very, very familiar fraction, if you will. Okay. What about combining two functions? In other words, what if I have a machine, I stick in an input, and that spits out an output. But then the output from the first machine kind of falls into a second machine, and it gives me a new output. So the first machine was the G machine. So I stuck an X into the G machine, and it gave me G of X. Now the G of X falls into the F machine, so it gives me F of G of X. So one way of writing it is F of G of X. The other way is writing F O G of X. The O is like of, F of G of X. And when that happens, we call it a composite function because it's sort of composed of two different functions. And now we want to, let's form some composite functions here. F of x, let's figure this out. Give me 1 second, everybody. So we have f of x is 2x minus 3, g of x is x squared plus 1. We want to find f of g of x, and then we want to find g of f of x. They're not necessarily the same thing. So f of g of x means I take g of x and I stick it into the f function. So instead of 2x minus 3, it's 2g of x minus 3. But g of x is equal to x squared plus 1. That's what we set up here. So now I got to distribute this out and combine and simplify, and I get 2x squared minus 1. Now for the other direction, g of f of x, so I'm taking f of x, I'm sticking that into x squared plus 1, so it's f of x squared plus 1, which is 2x minus 3 squared plus 1, because that's what f is, 2x minus 3. I FOIL that out, combine, simplify, and I get 4x squared minus 12x plus 10, and that is the story. So notice you get a different answer. Okay, inverse functions. An inverse function is something that sort of undoes what the original function did. So for example, you have if f of x equals 2x, now this is the symbol that we use for inverse, f inverse of x is equal to x over 2. That makes sense because if the first function doubled the number, the second function knocks it back in half, right? So you double the number, if you want to get back to the original number, then knock it back in half. The first function added 4, the inverse function subtracts 4, because if I started with 5, I add 4, I get 9. Now I take 9 and subtract 4, I get 5. So the inverse function is subtracting 4, because the inverse function is what gets you back to the original number. It gets you back to where you belong. Now, how do you find the inverse of a function? So there's a good trick. A lot of you probably learned this. If you have y equals 2x minus 3, you switch the x and the y, and then you solve for y. And you get x squared each side. X squared equals 2y minus 3. X squared plus 3 equals 2y. X squared plus 3 over 2 equals y. Pow, that's my inverse function. So my inverse function is x squared plus 3 over 2. And that is my story. By the way, when you graph a function versus graphing the inverse function, it's always symmetric with respect to that diagonal, the diagonal y equals x. There's always a symmetry with functions and their inverses. Okay, now not every function has an inverse, especially a function which is not a 1-1. If a function is not a 1-1 function, it won't have an inverse. Because you see, if you graph it, it doesn't pass the horizontal line test. So there's no inverse. Okay, well, that was 1.4. Now we have homework. I'm going to post homework for this section on Canvas, and I will see you guys next time. We'll get to the next section. Bye, everybody. It's been loads of fun. Let me, how to get out of this.